In this video, we will talk about map abstract data type and its implementation. This is the second topic of Module 8. The learning objective of this topic is to define map abstract data type and design and implement map abstract data type. Apply map class template defined in STL. Map abstract data type. A map is a container. A map stores a collection of ordered entries or pairs. Here, each entry or pair consists of a key and a value. Key and a value. Here, the keys must be unique. We cannot have duplicate keys in the map. And values don't have to be unique. So the several keys can map to the same values. And the entries or pairs in the map are sorted based on keys. So for example, here we have this entries or pairs. The key is for this entry, the key is a student ID, and the value is a student name. Here, the keys should be unique, and every student should have the unique ID. But the name don't have to be unique. Different students, they have different ID, but they can have same name. So for example, here in this example, the student with the ID 1001, then its value is Bob, or the name is Bob. And then the student with the ID 1003, its name is also Bob. So this is okay. But the ID should be unique. So the name don't have to the name don't have to be unique. The ID should be unique. So here the case must be unique, and the values don't have to be unique. And one more example. In this example, we have these entries. The key is a word, and the value is the meaning of this word. In this example, the first pair, apple, a round fruit of tree. The word is apple. Its meaning is a round fruit of tree. Here, the key, apple is a key, and a round fruit of tree is a value. Okay, the case type, this is a string, and the values type is also string. And these entries, we have 3 entries here. These 3 entries are sorted based on key, based on the word. So the first entry, its key is apple. Second entry, the key is bee, and third entry, the key is cat. These 3 entries, they are sorted based on the case, based on the words, not on the meaning of the words. So this is a kind of dictionary, and we have a word and the meaning of word. So in fact, in some programming language, the map abstract data type is also called the dictionary abstract data type. Okay. The operations of map. Here we have at least 5 operations of map. The first one is empty. This operation returns true if the map is empty. returns false if the map is not empty. Get size returns the number of entries in the map. Return type is int. And then this one, we call it index operation or the index operator. It takes one parameter k. This one is like an insert operation. If the k is not in the map, the index operator insert the entry with the k, return the default value. Okay, this is the and return the default value. If the k is in the map, we don't insert the duplicate k's. So we return the value corresponding to the k. So the when the k is not in the map, this index operator, it's a kind of insert operation. If the k is in the map, it's not an insert operation. It will return the corresponding value to the k. We will take a look at this example later. So for the map, this index operator, this one is very important. We need to understand this operator. And the next one is a remove operation. It takes one parameter k. This operation removes the entry with the k from the map. We'll remove the entry with this k. This is a parameter. And then the last one, make empty. This operation makes the map to empty state. That means remove all entries from this map. And then we have an empty map. Okay. Now let's take a look at an example. Now we have a collection of employee entries. Here in the employee entries, we have the ID and name. We use ID as k. We use name as value. Now we have 1, 2, 3, 4, 5 entries or 5 pairs. And the first employee, its ID is 1005. Name is Bob. 1005 is a k, Bob is a value. And now so the k, we don't have the duplicate case. 1005, 1003, 278. So no duplicate case. But here we have duplicate values. And the employee with the ID 1007 and 1008, they have the same name. So, but their ID or their case are unique. So the employees is a map object. And then we insert these 5 entries or 5 pairs in this map object. So we can use the index operator to do this. Employee is a map object name. We use the index operator. 1005, this is a k, and this is the value. This is value. So we use this index operator to insert this entry in the map object. So in fact, this statement, this index operator, this statement contains 2 steps. First step is the employees 1005, index operator 1005. It insert 1005 an empty string in the map object, and then assign Bob to the value of the k 1005. That means use Bob to replace empty string. So this means 2 steps. This statement means 2 steps. Now, if we already add the 1005 Bob in the map object, so we can print out cout employees 1005, index operator 1005. Now the 1005 Bob, this entry is already in the map object. This index operator will return the value of this K 1005, the corresponding value of this K. We will get the Bob. So this is the index operator, the very important operation in the map abstract data type. And we also have the remove operation. Remove operation, we pass the K value to the remove operation. This operation will remove the entry with the K 1005. Remove the entry with this K value. Okay, this is a map abstract data type. And now let's take a look at how to implement map abstract data type. So here we store a collection of entries. We can use array, we can use linked structure, and we can use binary search tree. Here the keys are unique, so we can use binary search tree. We will use a binary search tree to implement this implement map, because a binary search tree have the better performance. The time complexity for insert, remove, and search are all big O log n. So this is a binary search tree. It's better than array, better than sorted array, better than sorted linked structure. So here we use binary search tree to implement map. So in fact, we know the binary search tree and the set, they're same. So we also can see we use set to implement map. That means we store this, a collection of entries or a collection of pairs in a set. And we store these entries in a binary search tree. Now we have these 5 entries, and we insert these entries in a binary search tree. We get this binary search tree. The first pair 1005 Bob is stored in the root node. This is a binary node. This is a binary node. This is a binary node. And the 1005 Bob is stored in the root node. And then the 1003 Mary is stored in the left subtree of root node. So this is a 1003, and then 1002. 1002 is the most left node. 1002 Joe is stored in the most left node. And then the 1007, 1008. So this is a binary search tree we create for these 5 entries. Now we call this index operator employees 1006 Mike. This means we will add a new entry in this binary search tree or in this map. So we will find the right position for this new entry. It will be here, and then we create a new node for this entry. This is the leaf node 1006 and the Mac. Okay, so this index operator, the 1006, this K is not in the map. So the index operator will add this new entry in the map or in this binary search tree. Okay, now for the implementation, here we store entries in a set. So we know in a set, the elements are all sorted. So these entries are sorted in the set, and they are sorted based on the case. So here, the implementation, we store a collection of entries in a set, or we use set class template to implement map class template. So here we define a pair class template in pairs.cpv file. This is a pair class template. It has two attributes, K and value. The K type is K and the values type is V. So this is a class template. We have two type name in this class template. And all the comparisons are based on case. We can compare two pair objects. So we compare two pair objects based on case. All the case must be unique. We will take a look at this file later. And here we also define the set class template. This set class template is almost same to the set class template we defined in the first topic of Module 8, set abstract data type. The only difference is the iterator and the insert member function. So here we add an iterator constructor. We add this constructor for the iterator nested class, and the insert member function. This is the public insert member function. Its return type is not a void. Its return type is iterator. And the public insert member function called the private insert member function. The private insert member function return type is also iterator. So in the set class template, we defined in topic 1, set abstract data type, the insert return type is void. Here we change it to iterator. And now the last one, we add this maps.cpp to implement map class template. Map is a set of entries. So we store a collection of entries in a set. That means these entries are sorted. And we also have the unique case for these entries. And for this map class template, it has one private attribute. The private attribute is the map. The map is a set of pairs. And the case type is K, and the values type, this should be V. The values type is V. And we implement the index operator in map class template. We also implement remove member function in the map class template. Okay, the code files are contained in map.txt file. This file, I already upload this file to Canvas. So please download this file and review this code. In this code file, I put this 4.cpp files in this txt code file. Now let's take a look at the code file. This is in the map.txt file. Okay. Now, this is okay. The first file is pair.cpp. In the pair.cpp, we define pair class template. Here we have two type name, K and V. K is a case type. V is a value type. And the class template name is pair. And now let's take a look at the private attributes. These are private attributes. The K and the value. K's type is K, capitalized K, and the values type is a capital V. This is a class template. We have two type names. Okay, now the public member functions. These three, they are constructors. And the first one is a default constructor. This constructor has no any parameters. And the second constructor has one parameter. And this constructor has two parameters. So we pass the K and the value. This constructor use this two parameter value to initialize attributes. And then we have the get K, get value. Here the get value, this is not an accessor because we don't add the const here. So get value is not an accessor. We use a reference here. So we can change the return value. We can change the value. And then we define the set K and the set value, these two mutators. We pass the K's value to this parameter, and this member function will use a parameter value to set attribute value. Okay, and then we overload these operators. Equal, not equal, less than, greater than. These operators, these are member functions. So remember that in the employee class, we overload the operator, comparison operators. We implement the friend function. They are not member functions, but here, these operators, they are member functions. They are member functions defined in the pair class template. So we can see that when we compare two pair objects, we compare their case. If two pair objects, they have the same K, and then we see these two pairs, they're same. We don't care about the values. We only compare Ks. And also the not equal, we compare Ks. And the less than, we compare Ks. If the one pair object, its K is less than another K, and the K of another pair object, we will see the this pair is less than that pair object. So we compare case. The greater than, less than, we compare case. That means we compare two pair objects. We only compare their case. Okay, this is a pair class template. And then is a set class template. Here we define the set class template. The type name is C. This is same to the set class template we defined in the topic 1 of module 8. The only difference is here. The only difference is here. These are all same. Difference here. The insert member function. This is a public insert member functions. In the set class template defined in the topic 1, its return type is void. But here we change the return type to iterator. And also the public member function called the private insert member function. The private insert member function, its return type is also iterator. Now that means when we insert a new pair in the set, we will return an iterator representing this new node, or representing the new node contain the new pairs. So for example, we add this 1006 and the mic. Okay, I will redraw this. We add, for example, we add a new node in the binary search tree. This is a 1006 and the mic. We add a new node in this binary search tree or in this set, and the new entry 1006 and mic is stored in this new node. And then we return the iterator point representing this new node. So we have the iterator. In the iterator, we have a current pointer. So this current point to the newly added node. And the new pair is contained in this new node. Current point to this. So that we will return the iterator representing this new node. This is a public insert. The private insert is here. Okay, this is a private insert member function. Its return type is iterator. It's not the void, its return type is iterator. Here, after we add a new node as a leaf node, we will return iterator T, return the iterator representing this new node. And also here, this means we find the matched K in this set or in binary search tree. We will return the iterator representing the node contain this K. Remember that this else means we find the matched element in this binary search tree. So we don't insert duplicate, but we return the iterator representing this node contain the K. Okay. One more thing is we also add the iterator constructor. And this means we pass the node address to this iterator. And we return this iterator. Now I will show you this iterator constructor. This is an iterator. Okay, this is the iterator, the nested class defined in map class template. We add this iterator. We add this iterator. We pass the address of a node, and then this constructor set the current pointed to this node. So this equivalent to the current equal to P. So the current pointed to this node. We change the set class template to add this iterator constructor to change the return type of insert member functions to insert member functions. And then we use them for the map class template. Okay, now let's take a look at the map class template. The map class template is stored in map.cpp file. We include two header files, the pair.cpp and the map set.cpp. So in the map set.cpp, we define the set class template. And here the map is also a class template. We have two type names, K and V. And then we have the class template name map. This is a default constructor. And we have the print map member function, public member function. This print map public member function use iterator to access every pair in the map. So print out the key and the value. So this is the dereference operator of the iterator defined in operator. This is the increment operator defined in the iterator. And then we have the index operator and the remove member function. Map class template has one private attribute. Its name is the map. The map is a set of pairs. The map is a set of pairs. Here we have the index operator. The index operator will declare an iterator here and then declare a pair object probe. And now for this pair object, its key is this parameter key, and its value is a default value. It's a default value. And then we insert this pair object in the map. We call the insert member function to insert this pair object in the map. So the map is a set of pairs. Now we insert a new pair in this set. And then this insert member function return iterator. So we assign this iterator to here. And then we return the value, get value of this node. Okay. Now, for example, if we have the employees 1006, this means we will create a pair 1006 and the empty string. We add this to the map. We add this entry to the map, and then we return the corresponding value. We return the empty string. Return empty string. This is this step. And then if I add the equal to Mike, that means I will update this empty string as Mac. So that's why I say that this statement contains two steps. The first step, add the 1006 and empty string, this pair in the map, and then update the value, update the empty string as Mac. Okay, this is the index operator. And then the remove of member function, it takes one parameter, the k value. And this statement will create a pair object. Its name is probe. And then we set the k of this pair object. We call the set k, this member function, to change the case value. And then we remove the, we pass a probe to the remove member function. So remove the pair or remove the entry with this k. Okay, and then return. This is a remove member function. Okay, here I also add a test map.cpp file. Here we have the main function. Okay, no, we include the map.cpp file. We have the main function, and then we declare a map object. Its name is basket. In this map object, we store fruit pairs. The k is string, and then the value type is int. So the k is a name of fruit. So it's a string. The k is a name, fruit name. And the value is an int. Value is a number of fruit. The number of fruit. The number of fruit in the basket. So for example, in this basket, we have apple. We have 3 apples. And orange, we have 6 oranges. And we have grape. We have 50 grapes. Okay, and we have the banana. We have 5 bananas. Now the fruit name are case. The number of fruits, there are values. Now we declare some local variables, and we prompt user to enter how many types of fruit in the basket. Now assuming the user enter 4, so that means we will store 4 entries in this map, in this 4 entries in this map, yes. And then we use a for loop to prompt user to enter the fruit name and the number of fruit in the basket. Now assuming the user enter this value, apple 3, orange 6, grape 50, and banana 5. And then we call the print map to print the content of basket. We will get all these 4 entries information. Here, okay, here we can see we use a index operator to add entries in the map. So the basket name equal to count. We add, this is a way add entry. We add an entry in the basket. Okay, and then we call the print map to print out all the 4 entries. And then Okay, and then the next step, we prompt user to enter name. We want to change the number of fruits in the basket. So we prompt user to enter name, assuming I enter apple. And then the change to what? I will change this to 6. I add the 3 apples in the basket. And then we still call the index operator. Now the apple is already in the basket. So that means the apple, now that we have the apple 3, this pair in the set. Now that this statement will change the 3 to 6. We'll update the 3 to 6. Because the apple, this case already in the map, in the basket, this map object. So this means we will change the value, update the value. And then we call the print map member function to print all the pairs in the map. Okay, and then we also have this, we check which fruit. We prompt user to enter name. Now, assuming the user enter grape, and then we will print out there are 50. This is a basket name. This is a value. The value corresponding to this K. Now the name is, the K is grape. We will print out the value corresponding to the grape. We print 50. There are 50 grape in the basket. Okay, so here we still use the index operator here. And then the last one, remove. We prompt user to enter a fruit name. We will remove this fruit from the basket. The user enter, for example, the user enter orange. The user enter orange. This name is passed to remove member function. That means we will remove the entry with the K orange. That means we will remove this entry from the basket map object. Okay, this is a map. There is still one slide we will talk about is in the STL, the standard template library. It defines the map class template. So here this M is a lowercase m. In the STL, it defines the map class template. This map class template uses a binary search tree to implement the map abstract data type. So that means the time complexity for insertion, deletion, and search, they're all big O log n. So also we can use the iterator to access every entry in the map. So to use the map class template defined in STL, we need to include map header file. If we want to use the iterator to access every entry in the map, we need to include iterator, these two header file. Okay, so you can find the more information about this this class template. I think I attach a website, the URL of website about this map and set. Okay, this is all about the map, abstract data type, and implementation. So after you complete this video, you can move on to the lab 12. Okay, lab 12 is about the map. We will talk about map lab exercise in a separate video.